my computer. Just because we do have a couple of people who are out. So one last time, your packet link is posted now in the chat. So you can get in there and you can follow along. The warm-up, let's go through our warm-up. Questions 1A and 1B. It says, list all the factor pairs of each number. What do I mean by factor pairs? In other words, give me two numbers who multiply to be 12 in the chat. Give me two numbers that multiply to make 12 in the chat. Let's start with everybody. Give me two numbers that multiply to be 12 in the chat. Also, I see a lot of cameras are off today, maybe because of the snow. It's poor connection, but if you are able to turn your camera on, I would appreciate seeing you. Okay, I got 6, 2, 6, 2, 6, 2. I got a lot of people that said 6 and 2. There are more pairs than that. I got 3, 4, and 6, 2 so far. Any others? 4, 3, and 3, 4. They're the same, right? 3, 4, and 4, 3. Those are the same pair of numbers. Okay, don't forget, Katie, 12 and 1. Perfectly fine. Listen, before you write any of these down, here's what we're going to do. Today, when we factor a constant, which we will be doing, we're going to do this in a T-chart. We're going to put 12 on the top of the T-chart. We're going to list them in order. So the first number I want to list is 1 and 12. Although it wasn't the first one we listed in the chat, it's the first one I want you to list on your paper, 1 and 12. What comes after 1? 2. 2 goes into 12 6 times. What goes into 12 after 2? How about 3? 3 goes into 12 4 times. If I were giving the class a grade based on this question, you got a 50%. There are 3 other pairs of numbers that multiply to make 12. Can anybody think of a different pair that we didn't list? Can you think of a different pair that we didn't list? Now, mind you, we listed 3, 4, and 4, 3 is the same pair. 12, 6 is the same pair, and 12, 1 is the same pair. 6, 2 is the same pair. Good, Thomas. That's what I was looking for. Thomas, you said this pair, -2, -6. That is a different pair. What are the two other last pairs? You always have to make a completed list. I always make my list in order. Not only -2 and -6, how about 1 and 12? How about -3, Daniel, and -4? Good. Then we get -1 and -12. Okay. So when we make a list of terms, we want to make and consider all the pairs. These are different numbers than these numbers. These numbers are opposite, therefore they're different pairs. Let's do this again. Let's do this again for the number -8. Let's make a T-chart with -8. I'll take anybody in the chat. Give me a pair of numbers that multiply to make -8. I'll take anybody's first. I may not write it down first. Okay. I have 1 and -8. I have 4 and -2. I'm not going to write any of those down, but they are correct. Any others? 1 and -8 and 4 and -2. Here's what I'm going to write. I would like for you to write them down the same way I'm writing my list down. The first one I'm going to list, actually, let's start with 1 and -8. That's actually the last one I'm going to put down. I'm going to put a -8 in this left side and a +1 on the right-hand side. Somebody also told me 4 and -2. That's the second one I'm going to list. -2 and +4. Remember how I did this over here as I went in order. 1 and then 2 and then 3 and then 4. So let's start with 1. Let's do -1 and 8. That's the first one I will list. -1 and 8. -2 and +4. Thomas, you also told me what? You also told me, can you type that for everybody, Thomas? I want everybody to see what you wrote. And thank you in advance for typing that out. Thomas wrote 2 and -4. Now listen, my 2 on the paper is negative. Thomas's 2 is positive, and those are different numbers, aren't they? My 4 is positive. Thomas, your 4 is negative. Those are different numbers. So guess what? I'm going to list them because they're a different pair. So we have 4 pairs. What I also want you to do on your paper is negatives go on the left. Negatives go on the left. This is a rule for me. This is a rule for me. We had a negative product, so we need a negative and a positive. I can't use 2 negatives and I can't use 2 positives to make a negative product. I always list the negatives on the left. Again, I go in order, starting with 1, then 2. Well, if 3 doesn't work, then maybe try 4, 5, and 6, and 7 don't work, but maybe 8 will work. Make sure you have these lists written down. We're actually, I think, going to skip number 3. Let's finish with question number 2. Question 2, factor out the greatest common factor. I'll take any and every answer I can get from everybody. What's the GCF of question number 2? What is the GCF of 3x to the third, negative 12x to the second, negative 15x? What is the GCF? Lydia and Thomas, you said the same thing, but nobody knows what you guys said, what you all said, what you both said. I got 2 quick answers. How about Cornelius? What's the GCF of 3x to the third minus 12x squared minus 15x? Or Evie, what's your GCF in this one? 3x to the third minus 12x to the second minus 15x. Lavinia, good. Cornelius, you gave me only half of what I was looking for, but the first half is better than nothing. Cornelius, it's not just a number, it's a number and a variable. Okay, Gavin. It's a number and a variable. A number and a variable. So the GCF is 3, but they all have an x. So it's 3x to the first. Actually, because they don't all have 3, I can't take 3 out. They all have 1, so I can take one of them out. Okay, so let's factor out the GCF. What I told you to do, and was part of your quiz yesterday, is divide each of these by 3x, and you need to put the 3x on the outside. Factor something out means something is outside of a set of parentheses, and there's something more inside. Now we're going to reduce. 3 divided by 3 is 1. X to the third divided by x is x squared. Good, Katie. You can either write the minus down or just think to yourself, a negative divided by a positive is a negative. 12 divided by 3 is 4. X squared divided by x is x. You could think to yourself, a negative divided by a positive is a negative. 15 divided by 3 is 5. And x divided by itself, they cancel each other out. This is the answer. Just be careful of this middle term. I saw somebody with an incorrect middle term in a private message, so this would be your answer. You're going to divide each of these by 3. You're going to take away 1x from each of them and put the 3x on the outside. Okay, well, this is something that we are going to put on the back burner, but you're going to use factoring out a GCF a little bit later. We're going to use factoring a GCF a little bit later. Just so I know and I reassure myself. Again, I'm going to post the link to the packet in the chat in case you didn't pick up a packet or couldn't get to school in time. This is just what we're going to be doing. Here's our lesson. Here's where it begins. Today, we're going to practice factoring quadratic trinomials, 3 terms that have a second degree. When I refer to the quadratic trinomial, I want to always make sure it's in standard form first. Make sure that it is in standard form before we begin. What we're going to try to accomplish is to write this trinomial in its factored form, the product of 2 binomials. We're going to start with one trinomial and write it as the product of 2 binomials. This is called factoring, is to break it up into factors. It also is going to reverse the distribution process. So if I were to tell you what you're going to be doing, today we're going to unfoil. We're going to do the reverse of FOIL. Instead of distributing together, we're going to pull factors out. There is a method to this. Let's take a look at what this says. So I want to make sure I have a quadratic trinomial in standard form. If it's not in standard form, we have to write it in standard form. Now this doesn't appear in your notes, so I'm going to add this to my notes for you. You want to always make sure that it starts out in standard form. Then you're going to find two terms that multiply to make x squared. These terms become the first term in each binomial. So we're going to think about x squared and think, what do I need to multiply by itself to make an x squared? That's an x and an x. Most of your answers today will start with an x and an x. What you're going to do with this x and x is you're going to start writing two binomials and start each binomial with an x. So again, you can add this. This is step one. You're going to factor apart x squared into x times x and put 1x at the beginning of each set of parentheses. The second step takes a lot of time. Then you want to find two numbers that blank to make c. Where's c? Well, c is the constant term at the end, and blank to make b. b is the coefficient of the linear term, our term in the middle. You want to find two numbers that multiply to make the constant and add to make the coefficient of the linear term. These numbers become the last terms in your binomials. So I'm going to call these number and number. These two numbers have to multiply to make c. These two numbers have to add together to make the number in the middle. We're going to use the t-chart to help us to do this. What do we do with the t-chart? We're going to factor the constant because we want two numbers that multiply to make c. So we're always going to write this down. It's not going to be mentioned again. We're going to put the c on top of the t-chart. And we're going to find two numbers that multiply to make the constant c. And we want them to add to make b. So you're going to see me do this twice on this page. I know somebody might have questions. I know a lot of you might have questions, and it won't make sense until we do one or two of them. So why don't we get to it? Let's do the first two exercises down below. So what I said earlier is we're going to put the value of c on top of my t-chart. So take the value of 12 and put it on top of this t-chart. Now, just like our warm-up, we factored 12. I go in order, starting with 1 and 12. Now, if you don't know what numbers go into 12, certainly you can use a calculator, like 12 divided by 1. So 1 and 12. Backspace it. 12 divided by 2, 2 and 6. So I'll put 2 and 6. 12 divided by 3, 3 and 4. 12 divided by 4, 4 and 3. But 4 and 3 is the same pair of numbers. I don't want to list 4, 3 because they're the same numbers. Once I repeat, I'm going to draw a line, and then I'm going to put the negative pairs. -1 and -12. -2 and -6. -3 and -4. The first time we do this, we're going to write every single pair. After the first time, we might look for shortcuts. We might only have to write like 1 or 2 or 3 pairs. We don't have to write all of them. Because what we're trying to find is we're trying to find a value that adds up to be the coefficient of the x term in the middle. So I want to add all these numbers. I want a sum to make the middle number 8. I'm looking for 8. That's the goal. The goal is to make it 8. So we're going to add these terms together. 1 and 12 make 13. Is 13 8? No. This is not the right pair of numbers. Let's go with 2 and 6. Add them together. Do they make 8? Yes. That's what we want. This is the pair that works. So I'm going to circle this pair. Actually, I can circle all the way through. We're going to circle this pair. And what is our answer going to look like? Our answer is going to be a pair of factors that unfoils the trinomial. So I'm going to do this. I'm going to start by writing 2 sets of parentheses. What we said earlier is we want each of these to start with an x to make x squared. So I'm going to start each of these with x and x. Since we found the pair that makes the middle term, I'm going to take these two numbers and put them after each x, one at a time. I'm going to put a 2 here and put a 6 there. Because my 2 and my 6 were positives, we're going to put plus signs. And this is our answer. I'm going to take better notes when I do this in class because I was realizing as I was watching students do our quiz that although they had their packets, they didn't know what the answer looked like because they weren't circling them. They weren't circling answers. Maybe they wrote it down and they had to pick between the step before and the step after. So I want to be a little bit clearer for you that this is the answer, what we're looking for. We're looking for two binomials who multiply to make the trinomial. Now, how can I check this? Can you tell me how I can check my answer if my answer works? What we started with was a trinomial and we factored it apart into two binomials. How do I know that this is the same thing as that? What can we do with our answer to check it? It's one thing to do the question. It's another to know that the question that you do is correct. Any ideas? Well, when we had two binomials before, what we did was we FOILed them, or we did rainbow, or we did box, and we can multiply them together. Yes, we can add these numbers to make 8 and multiply these numbers to make 12, and that should work. It's designed to work. I don't mean to waste time today. Hopefully I'm not wasting your time. I can't tell who's paying attention and who's following along because I can't see anybody except for two of us, which is disappointing to me as your teacher. Hi, Gavin. Thank you for waving. I do see you. And I do see Thomas. X squared. 6x and 2x makes 8x. And 6 times 2 is 12. So this checks. This is not the answer. This is the check. The answer is still this up here. We're going to do the same thing, but I'm going to do it a little bit easier, more convenient for you. On the top of the T chart, I'm still going to pick the number C. I'm going to pick the number 12, but instead of writing the full list, I'm going to go one at a time and start adding them together as soon as I make them. Since 12 is positive, I need a positive times a positive to make a positive. Let's start with 1 and 12. The number I want to add, the magic number is the goal, 13. The number in the middle is 13. If I add these together, look, I found the number right away. They make 13. So I'm going to circle this pair, and all I have to do is write my final answer. I'm going to write x at the beginning of both factors, and I'm going to take my two numbers and fill in the second term, a 1, a 12. Both numbers were positive, so I'm going to put 2 pluses. What is our answer? Our answer is this. That's our answer. I'm not requiring you to check these because it's designed to work. The way we did it is designed to work. These two numbers add to make 13, and they multiply to make positive 12. This one's going to work. Hey, folks, do you have any questions right now for me? The next page gets a little bit tougher, but it's not completely that much tougher. Let's turn to our second page. You might scroll in your computer, scroll down. All right, the top of the second page is actually the beginning of our process. Before we do what we did on the front page, I have to tell you that always the first step of factoring is to look for a GCF and factor it out. Not every time will we find a greatest common factor, but when we do, we'll factor it out. Once the GCF has been pulled outside, then you can refactor the remaining polynomial using the previous method. So the first thing we're going to do is look for a GCF. Everybody in the chat, if you don't respond, I'm going to put you in the waiting room like a punishment. Not like a punishment. What's the GCF of the exercise we're working on? Question 3. Is it a number? Is it a variable? We did one of these in a warm-up. Thank you, Thomas. Lydia, I think that's half right. Evie, I think that's only half right. I think you have extra things in here. Do all these numbers divide by 2? Do all these terms have a variable? Not the one at the end. Okay, don't have to apologize. Listen, you're entitled to get something wrong. What you're not entitled to do is just sit there and not practice. You got to practice. Rumor has it the greatest common factor is just 2, not 2x, just 2. Good job, Katie. So we're going to factor out a 2. So I want a 2 on the outside. So there's my greatest common factor. Let's divide each of these by 2. Look, I didn't put anybody. See what happened? I didn't put anybody in the waiting room. Let's divide out a 2 and a 2 and a 2. So take away a 2 from 2x squared, it becomes x squared. Take away a factor of 2 from 20, and 20 turns into 10. So 10 what? 10x. Take a factor of 2 out of 50, it makes it 25. All right. So this is our factored. We factored out our GCF. Now you can factor the remaining polynomial. That's the remaining polynomial. What number do I put on top of my t-chart? Am I going to put 50 or 25? Good, Rex. Am I going to factor out 50 or 20? Am I going to put 50 up here, or am I going to put 25? Am I factoring the original or the remaining polynomial? The answer I'm looking for is 25. I'm going to put the 25 on top because we've already factored and reduced it by a factor of 2. Get the calculator out if you need to. If you don't know what divides 25, let's start with 1. 25 divided by 1, well, that one was obvious. 1 and 25. Now, before I do all of the list, let's be smart about it. I know you paid attention on the front page. If you could tell me what the sum I need these to add to become. Let me rephrase that. I know you've been paying attention. If you tell me that these numbers have to add to be this number in order for me to consider this to be a success. Try again. Look here, it's one of these. Lydia, correct. What number do these have to add up to be? Try again, Daniel. That's correct, Daniel. Caitlin, any ideas? Lavinia, any ideas? Rex, any ideas? Cornelius, that's good. If you need to look back a page, Gavin, look back a page. I know it's upside down for you. Look, I had add 13. Where does the 13 come from? The first, the middle, or the last term? Hey, first, middle, or last term? Cornelius, good. First, middle, or last term? Come on. Still waiting for, okay, Evie, that's good. It's the middle term. So we want these to add up to be 10. So as soon as I get a pair that adds up to be 10, it's the middle term. So let me write the word middle up here in case you want to write that down for your notes. Let's add them as we go along. And once we get 10, we could stop. We got to keep going. We didn't get a 10. Cross it out. Let's see. Does 2 go into 25? I think the answer is no, but the calculator will tell me for sure. It doesn't go in evenly. Does 3 go into 25? No. Does 4 go into 25? No. Does 5 go into 25? Yes. 5 goes in 5 times. Let's add these together. They make 10. Stop. We have what we needed. We have 2 terms, 2 numbers that add up to make 10. So here's what we're going to do. We're going to factor this. Don't forget, you need to always begin with the greatest common factor. If you factored something else, it belongs as part of my answer. So I'm going to put 2 on my line. Each factor pair starts with the factors of x squared, which were x and x. And I'm going to take the two numbers from my table that successfully add up to be 10. They were 5 and 5. Both of these were positive, so we're going to put plus and plus. So what is our answer? 2, our greatest common factor, x plus 5, and another x plus 5. These are the factors, and these are your numbers from the T-chart. Here's our answer. Here's our answer. It has a GCF, an X, and a number from the T-chart. I'm going to write T number and T number. A 5 and a 5. Let's put T number here and T number here. All right, folks, any questions? Ladies and gentlemen, children of all ages, any questions? All right, seeing that there were no questions, maybe we'll slide this down. Now, the next section involves negative numbers, minus signs, negatives. Most of the process starts the same way. It starts out by first, we're going to look for a GCF. Number 4, is there a greatest common factor? Number 4, is there a greatest common factor? If so, what do you think it is? Is there a GCF of number 4? What do you think it might be if there is one? Thomas and Haley, I agree with you. All of our coefficients are even. So I know 2 goes into all of them. Does 4 go into everything? All of the terms have an x. Do they all have more than one x? If they all have more than one x, we're going to take more than one out. I haven't gotten any new answers in a long time, in a couple of seconds. Still waiting for people to think. Caitlin, what are you thinking? What's our GCF? Narcy, what are you thinking? They all have an x, so I'll take an x out. They don't all have more than one x. Good, Evie. Good, Caitlin. I agree. Has an x, and they're all divisible by 4. Maybe I gave you enough time to divide out a 4 and see that it worked. Okay, so 4x is our GCF. What I'm actually going to do, this is not cheating. I would recommend you do this. I'd start putting 4x on my answer line because I don't want to forget it. Your answer needs your GCF there in order for it to be correct. Okay, so next what we're going to do is we're going to divide each of these by 4x. Over here, I'm going to reduce it. Put the 4x on the outside and reduce the 3 terms in my trinomial. 4 divided by 4 is 1. X to the third, take out 1x. Now it becomes x squared. Positive divided by a positive is a positive. 36 divided by 4 is 9. X squared, take away 1x. You have x left. A negative divided by a positive is a negative. 144 divided by 4 is 36. All right, I'm going to ask everybody 2 questions. I hope you can answer both. What's the T-chart number and what's the add number? What's the T-chart number? What number goes on top of the T-chart? And what's the number in the middle? Whoops, I gave you the answer to the add number. Let's see who's paying attention and typing today. Let's see who's taking an active role in their participation for their knowledge of the day. Interesting. I got 2 different answers for the top number on the T-chart, but I got the same answer for the add number. The add number, I think, maybe we shouldn't call this the add number. Maybe we should just call it middle number. Our middle number is 9. So we want the middle number to be 9. Oh, good, Lydia. And the top number on top of the t-chart isn't 36 because there's a minus in front of the 36. Remember I said we have negative numbers, we have to pay attention. So we're going to need to pay attention to that. So the top number is negative 36 and the add number is 9. So as I said in our warm-up, in order to make a negative product, I need one negative and a positive. My negatives go on the left side. I want you to do the same. I won't be able to tell you why that is until after our long weekend. So I'm going to start with negative 1. Negative 1 goes into negative 36 times. If I add these together, do they make 9? That means no, keep going. Let's divide by negative 2. Negative 2 and positive 18. Do these add together to make 9? We're getting closer. They make 16, but I'm looking for 9. Cross it out. Let's try 3. Does negative 36 divide by negative 3? Yes, it does. Negative 3 goes into negative 36 12 times. Add these together, that makes 9. That's my add number. So I'm going to circle these. And now what? Now I can factor this and put it on my answer line. What are the factors of x squared that always begin each of these binomials? X, x. What were the numbers from the t-chart? One of them was a negative 3. The other was a positive 12. Do you see how one of them is negative and the other is positive? X minus 3 and x plus 12. Narcy, can you check your chat for me? Thank you. And then respond. Thank you, Narcy. So here's your answer. Your answer has the GCF, has the factors of x, has your t-chart numbers, t number and t number. Here's your t numbers right there. There's your GCF. Don't lose any. If you lose any of these pieces, then it's not completed correctly. Looks like we have 11 minutes. There's a couple exercises at the bottom. There's something on the next page. Let's see how far we can get. All right, is there a GCF for number 5? Is there a GCF for number 5? If so, what is the GCF of number 5? Is there a GCF for number 5? If so, what is the GCF of number 5? Do each of the terms have an x? No, they don't. They don't all have an x, so I can't take an x. The 3 numbers, now the number in the front here that I don't see is a number 1. The only thing that divides 1 is 1, and it would come out the same, as somebody just told me, it would come out the same. So I would say that there is no GCF aside from 1, and 1 doesn't help you. You could use 1, but it doesn't do a thing. So then what goes on top of our t-chart? What's our middle number? I'm just going to call it middle now. Negative 12. And we're going to factor 27 and figure out which pair makes negative 12. Now, wait a second. Am I going to get an answer using 1 and 27? Am I going to get an answer that adds up to be negative if I use 2 positives? Yes or no? Does that make any sense? I don't think that makes sense, Caitlin. Caitlin's actually telling me, no, it doesn't make any sense. Should I use 2 positives to add up to be a negative? No. What should I do instead? Let's add 2 negatives. But let's say I didn't, well, sure. Let's use a negative and a negative. Do you notice I switched both of their signs? I switched both of their signs. If I add these together, I make negative 28. See, 27 divided by 2 doesn't go in. 27 divided by 3 is 9. So let's use negative 3 and negative 9. add together, makes negative 12. Caitlin told me that before I found those numbers. Negative 12 is the middle number. So I don't need to continue making a list. So I did that as quickly as possible. It took us 2 tries. There was no GCF, so I don't need to worry about putting something out in front. I'll just start my parentheses. Each parenthesis starts with how you factor a part of x squared. That's always x and x. And my t-chart numbers. 3 was negative, 9 was negative, and this is our answer. If I multiply these back together, firsts, got it. Outers and inners, negative 9x, negative 3x makes negative 12x, got it. Last, a negative 3 times a negative 9 is a positive 27, got it. This one checks out. Caitlin, that was a good idea. And you know what? I'm going to ask the class to do the same. Hey, class, if I ask you to type this answer right now, your homework will ask you to type your answers. 30-second practice. You have 30 seconds on the clock. Type your answer in the next 30 seconds. I want to see this written in the chat just so I know what you know the answer is going to look like. I want you to type x minus 3, x minus 9 in parentheses. Just 30 seconds to amuse me. Good, Thomas. Good, Lydia. Gavin, good. This is what your answer is going to look like. It's a set of 2 sets of parentheses, x minus 3, x minus 9. I'm waiting to see Lavinia's. I'm waiting to see Rex's. I'm waiting to see Daniel's and Katie's and Cornelius's. Narcy, I'm waiting for you to say anything to me today. Daniel, that's good. That's still not everybody, folks. Rex, where are you? I'm waiting for you to tell me something now. Lavinia, you still there? Did you give me one? I don't remember calling on you. All right, that was supposed to be a 60-second thing or a 30-second thing. I'm wondering if you're even there. Okay, last 2. Number 6. Number 6. Is there a GCF? Yes. What is our GCF? It's a 2. Let's factor out a 2. X squared minus 3x minus 54. The middle number is negative 3. The top of the t-chart number is negative 54. In order to make a negative product, I need 1 negative and 1 positive. Negatives go on the left. Negative 54 divided by negative 1. That's what we're always going to start with, is negative 1. Negative 1 and 54. Add them together, they make 53. That's not close. Let's see, negative 2. Let's divide it by negative 2. Negative 2 and 27. Add these together, they make 25. Getting closer. Does 3 go into 54? Actually, it does. Interesting. Negative 3 and 18. Add these together. That makes 15. Wow, we are getting closer. Does 4 go into 54? Actually, it does not. Does 5 go into 54? Well, it doesn't end in a 5 or a 0. Does 6 go into 54? Yes. 6 goes into 54 9 times. Negative 6 and 9. Add these together. Wait a second. Look closely. Look closely. Is this the middle number? Yes. Is this the middle number? No. No. I got one no in the chat. We want the middle number to be negative 3, but we get positive 3. This is good. This is good. This is not great. It's good. If we get the opposite number, what you want to do is switch the signs of both numbers. When it crosses this line, it switches its sign. Positive turns negative and negative turns positive. That will give you the number you are looking for. If you get an opposite, that's good, because that means you're one guess away from the right answer. Let's finish it. I have a feeling you're going to get this wrong. Let's start with x and x. Let's start with negative 9 and positive 6. Can you tell me why this is wrong? Caitlin, you got it right, though. What's my answer missing? What's my answer missing? put a 2 in the front. That's your greatest common factor. All right, we're gonna have 1 minute to work on the last one. The last one is my least favorite one. The middle number is -2. Let's divide 9. Now I should use 2 negatives because using 2 positives gives me positive answer. Let's do 3 and 3. There we go. 3 and 3 makes 6. All right, let's use 2 negatives instead. Change both signs, -1 and -9. Oh, wait, that gave me the opposite of this one. -3 plus -3. Do any of these pairs work? Do any of these pairs work? When no pair works, what do we call it if you can't factor something? If you can't factor a number, like the number 17, we call that prime. This polynomial is prime. If it doesn't factor, then we would just not answer it. We tried the best we can to answer it, but this one does not have any answer to it.